Dynamics studies the causes of motion, forces. A force is a push or pull that can change the state of rest or motion of a body. Its SI unit is the Newton, N. Newton's first law of inertia: a body remains at rest or in uniform motion in a straight line unless acted on by a net external force. Inertia is the tendency of a body to resist change in its state of motion, and it depends on mass. Newton's second law: acceleration is directly proportional to the net force and inversely proportional to mass. Force equals mass times acceleration. 1 Newton is the force that gives a 1 kilogram's mass an acceleration of 1 m over s squared. See how the arrow for velocity can change length or direction. Acceleration is that rate of change, so you can accelerate even while slowing down or while turning at constant speed. Newton's third law: for every action there is an equal and opposite reaction. These forces act on different bodies. Momentum P equals mv is the quantity of motion, measured in kilograms times m over s. Friction opposes relative motion between surfaces in contact. It can be reduced by lubrication and ball bearings, but is also useful for walking and braking. Impulse equals change in momentum. Fdelta T equals delta P. In an isolated system, total momentum before interaction equals total momentum after it. For circular motion, the inward resultant force is mass times velocity squared divided by radius. Centripetal force is not an extra force, but the name for whichever real forces supply this resultant. Watch the arrow pointing into the center of the circle. Even when speed is steady, velocity keeps turning, so acceleration is toward the center. That is why centripetal acceleration is v squared over r. A common mistake is thinking constant speed means zero acceleration. Do not pair action and reaction on one free body diagram. They act on different bodies. Example: for m equals 1.5 kilograms, v equals 3m over s, and r equals 3m, acceleration is velocity squared divided by radius equals 3m over s squared. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. For a numerical, list the known quantities in SI units, identify the unknown, choose one equation containing those quantities, substitute with signs, and give the final value with unit and sensible significant figures. Follow the 4 boxes in order. Listing knowns before choosing an equation stops you from forcing the wrong formula, a common exam mistake. For a law, state the controlled condition as well as the proportionality. For a diagram, label forces, rays, distances, directions, or circuit components before using it in an explanation. Treat each checklist item as a gate. Skipping labels or units is how marks disappear even when the idea was right. Finally, check the dimensions and whether the answer has a realistic direction and size. Treat each checklist item as a gate. Skipping labels or units is how marks disappear even when the idea was right. Suppose an exam asks for a connected explanation of dynamics. Begin with this precise statement: dynamics studies the causes of motion, forces. Build the answer as a chain, define the idea, state the relationship, then name the consequence. Examiners look for that connected thread, not isolated facts. Then add the related idea that a force is a push or pull that can change the state of rest or motion of a body. The link matters because a complete answer must show both the governing idea and its consequence. Finish with the supporting point that Newton's first law of inertia: a body remains at rest or in uniform motion in a straight line unless acted on by a net external force. This definition mechanism, or method dash, consequence pattern earns more credit than a list of isolated words. Build the answer as a chain. Define the idea, state the relationship, then name the consequence. Examiners look for that connected thread, not isolated facts. Do not treat scalar and vector quantities as interchangeable. Omit the condition attached to a law, or substitute centimeters and grams into an SI equation. Left side, number plus unit only. Right side, the arrow adds direction. If a quantity needs an arrow to make sense, like force or velocity, it is a vector. If direction would be meaningless, it is a scalar. Distinguish a quantity from its unit and a graph's slope from its area. In force diagrams, include only forces acting on the chosen body. Compare the two graphs. On distance time, steepness is speed. On velocity time, steepness is acceleration, and the area under the line is how far you moved. Mixing those meanings up is the classic error. A final check should confirm that every part of the prompt has been answered and that the terminology matches the chapter. Treat each checklist item as a gate. Skipping labels or units is how marks disappear even when the idea was right. Practice. Define momentum, give its equation and SI unit, and name the two factors on which it depends. Answer: momentum is the quantity of motion and equals mass times velocity, P equals mv. Its SI unit is kilograms times m over s, equivalently n times s. It depends on mass and velocity. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic.